Yep. And have you watched Interstellar?
Oh yeah, it's a good movie.
Yep. In that, like, Cooper goes to another galaxy, and I guess inside a black hole, and he tries to communicate with his daughter. So,
Mhm.
actually, is that possible? Like the time travel that Cooper does with Murph? Suppose
So,
if we get any sort of message from the aliens in the coming future, so as a person from Earth, should we respond to it or ignore it?
well, relating to this idea I mentioned earlier, the cautious thing to do
Yeah.
would be to not respond, to stay quiet, take at face value the claims that aliens have already visited, because the bar
Is dark matter really dark, or we don't know its color?
is very weak. So it doesn't absorb light, it doesn't emit light, it doesn't scatter light, and then therefore it's dark. We can't see it.
Okay, so Everest Base Camp, that means a very tough trekking then.
Yeah, right. Flew into Lukla, spent some time in Kathmandu, flew into Lukla, and then did the usual 1,000 feet elevation a day, so 8-day trek or something.
Yeah, but right now it's quite easier for trekking. Uh, so if you again see the videos of that place, it's not that it used to be 30, 40 years ago, but it's very comfortable right now. And the helicopter also goes directly to the base camp.
Oh,
So it's
yeah, we did,
quite good.
we did it more the hard way.
Yeah. So how are your days going right now?
Good. I'm teaching and doing research, and Arizona's a nice place in the winter. Weather's very good.
Yep. Actually, when I hear about astronomy and all these related things, the one question that mostly comes to my mind is that what is the actual importance of understanding the universe? I mean, countries spend tons of money just to know about a small detail about a body that is thousands of light years ahead from us. Don't know what's there. And why should we learn astronomy?
Well, nobody has to learn astronomy, of course. It's a subject that has a long history, the oldest
Yep.
science, because people always cared about the sky. So I would say it's built into our DNA, into our history. All cultures in the world cared about the sky. They navigated, they kept time, calendars. So astronomy is foundational to human civilization and human culture. That's one reason to learn it. It's part of learning history and culture across the world. Every part of the world has used it. That's one reason. The other reason is that
Yep.
it's a high peak of human curiosity to learn about a universe that's so vast and old, and to realize you can understand it through the tools of science. So it's not a lab science. You have to use telescopes and maybe spacecraft to go into the nearby universe. Um, so it's an intellectually challenging pursuit to figure out how the universe works, and it's something only humans can do. There are animals I think are intelligent, elephants, dolphins.
Yeah.
They're not going to figure out the universe they live in. So it's a uniquely human pursuit. And then, and you mentioned the money that might it might cost to do this. Astronomy is actually pretty cheap. If in terms of the money that the world spends on science and research, astronomy is a very small player.
Okay.
So you get this knowledge for what I would say is a good deal. Now, big telescopes, of course, the biggest telescopes in the world cost quite a lot of money, but you can get a very nice little telescope for a couple $100 that lets you see amazing things. So the floor on astronomy recreationally is actually quite cheap. You can't do genetic engineering if you're an average person. There's no amateur science in other areas, but astronomy is an area where anyone can participate.
Like you discussed something, a very important thing, that is astronomy is a very cheap kind of science. I don't want to use the word cheap here, but it costs quite less amount of money. But if we compare it with other subjects such as the medical science needs more investment because it is needed to save the people.
Mhm.
Similarly, if we see it with computer science, then it has similar reasons to it because computers are now required for day-to-day activities. But learning the modern astronomy, like we are actually studying about a black hole that has no connection with a human being in its daily life.
Hmm.
And should that thing actually be studied?
Yeah, so I think that's I don't think that's a bug. I think that's a feature. It's a powerful
Okay.
part of astronomy that it's abstract, that it's outside. I mean, we love music. Humans have used music and love music for thousands of years, and that doesn't make you richer. It doesn't help save lives, but music is essential. So I'm just happy to have astronomy as part of the way we use our brains, and then it's a very powerful thing to do. It's never going to be the biggest priority in any culture or civilization. Um, so, I'm not ashamed about pushing astronomy as an important thing, even in a
Yeah.
world that runs on money and where we need to spend money on health and nutrition and other important things. Like I said, in the United States, it's a very small percent of the research pie that's spent on astronomy. 1%, maybe less.
Yep. In USA, it's that in countries like ours, these subjects are not even a concern, because here we do not even care about astronomy. So I find a bit sad, because there are many of my friends who try to know about astronomy, but there is no any resources and all
Mhm.
those related things. But yeah, this is how currently the world is moving. So mm, as a normal guy, so I actually wanted to learn the thing about black hole. So when we hear the word black hole, that we get to learn things like it's an object that has so much of gravitational force that even light cannot escape from it. So that's the thing that I and most of my friends and all the students, we have learned this in our school life, and this is the thing that we have been knowing. So since black hole destroys everything, so is it actually an important thing for the universe?
Black holes are actually quite a small feature of the universe. If you actually do the look at where all the mass in the universe is, in stars and galaxies on very large scales, in the sort of census of matter in the universe, black holes are about one thousandth of a percent of the universe. So
Yeah.
in total, they don't really amount to that much. They're very interesting and very esoteric, and they draw people's attention. But in that global sense, they're not a major component of the universe. However, every galaxy, we think, has a black hole at the center, which again is a small fraction of its overall mass. The Milky Way has a 4 million solar mass black hole, 4 million times the mass of the sun. But the Milky Way weighs several billion times the mass of the sun. So again, it's a very small fraction. Um, and then dying massive stars leave behind black holes, and we've found those, and there are probably 10 million in the Milky Way in our own galaxy, of which we can only study the nearest dozen or a few dozen. So there are not that many black holes really known well or studied well, but we do understand them pretty well after a century after they were predicted by general relativity, and maybe half a century after they were first discovered. So we've learned quite a lot about them.
And can any galaxy exist without a black hole?
It's not clear. Nobody has found a galaxy yet that doesn't have a black hole. Sometimes the data
Yeah.
are not good enough, and so we can't rule out a very small one or smaller than average one. But every galaxy where people have looked hard with tools that should be able to see one, we find one. The Milky Way is one of the more modest black holes. The big galaxies in the universe have black holes that are 10 or 100 times more massive than our galaxy's black hole. So it's one of the smaller ones.
So, in comparing to other galaxies, the Milky Way is not that much important, you mean to say?
Well, the Milky Way, the black holes in galaxies seem to scale or correlate with the mass of the overall galaxy. Bigger galaxies grow bigger black holes. Milky Way is a sort of medium-sized galaxy, and it seems that our black hole has been starved for much of its history, so it's not grown as fast as some other black holes. That's one of the research agendas of astronomy, is to figure out how black holes, well, how they form in the first place
Yeah.
in galaxies, how they grow, how the way they grow relates to the way the galaxy grows, things like that. What makes them bright or active and what makes them dark or silent, because they can be both ways.
And can even our sun one day be a black hole?
No, our sun is too low in mass, so the fate of our sun is well understood. The sun, late in its life, will lose some of its mass. It will blow off about a third of its mass in gas as a red giant. And then what's left, the two-thirds that's left, will collapse when there's no more fusion into a white dwarf. So, which is a very collapsed, a very condensed state of matter that doesn't emit light, but it's not a black hole. So the sun is, you know, way short, is well short as a star of forming a black hole. You need a star that starts about 10 times the mass of the sun to leave behind a black hole.
And will even the solar system that we live will get trapped inside a black hole one day?
No, black holes are rare because only the most massive stars form black holes. Most stars are low mass. Um, there are many more stars that are smaller than the sun. So the typical star is small, even small compared to the sun, and dies as a white dwarf, not a black hole. So only about 1 in 1,000 stars die as a black hole.
Yeah.
And that means that the nearest examples are actually not that close. The nearest stars are a couple of light years away. The nearest black holes are a couple of hundred light years away. So they're quite rare, and the nearest examples are quite far away, actually.
And when we actually hear the stories related to black hole, sometimes I feel like, are black hole actually the garbage disposal in the universe, dumping matter somewhere else?
Well, they definitely are a place where it gets trapped and can't get out.
Yep.
That's the definition. But like I said earlier, in the universe, there are 0.003% of the universe. So it's not much of a trash can if it only holds 0.003%. So it's not a good
Yeah.
way to get rid of a lot of stuff. But it does seem to be a tomb, a final resting place of whatever goes in. There's no way in physics that matter can get back out, or the radiation can get.
And can we create such object in any lab?
We're very far from that. Maybe luckily, it would sound scary if we could do it. Um, there was a scare 10 years ago about CERN, the Large Hadron Collider, but maybe that in the enormous densities that happen in a particle accelerator, for a very short fraction of a second, you create very, very high densities when you make these collisions. And so there was a scare that CERN could make miniature black holes. And maybe scientists there, they knew that it was not likely or possible, but it got so, in Europe especially, it became such an issue in the newspapers that the scientists were forced to do a very careful study, and they wrote a report. And even the best accelerator in the US or Europe or anywhere in the world, which is the way you make very high densities of matter, falls far, far short of making even a tiny black hole. Falls short not by a factor of 2 or 10, but by a factor of thousands. So we're very far from making even a miniature black hole. And if Stephen Hawking was right, even if we made a miniature black hole, it wouldn't last very long, because his theory says that they evaporate and disappear, just fizz away into radiation. And the little ones fizz away quickly, and the big ones, like the sun-sized black hole or a galaxy-sized black hole, they take a very long time to evaporate. So even if you made a black hole through some technology, maybe in the future, it would disappear almost immediately, in a fraction of a second, according to Hawking.
Yep. And have you watched Interstellar?
Oh yeah, it's a good movie.
Yep. In that, like, Cooper goes to another galaxy, and I guess inside a black hole, and he tries to communicate with his daughter. So
Mhm.
actually, is that possible, like the time travel that Cooper does with Murph?
No, they were using artistic license. Now that was a good movie. There are
Yep.
movies where the science is good or not so good. That movie had as its main science consultant Kip Thorne, who's a Caltech professor who won a Nobel Prize for the gravity wave experiment. So they had very high quality consulting on that movie, and most of the science was very good. But it's a movie, so you have artistic license. You have to tell a story, and even Kip Thorne, I'm sure, was fine with the fact that some things in it, the movie, were not true or couldn't be true. So that was an example of a pure speculation. I don't know that it's ruled out, absolutely.
Yep.
It was definitely pure speculation.
And except that, uh, what are the other scariest thing in the universe that you think are not being discussed in the general public?
I mean, this is a sort of a strange answer to that, but we're on the verge of finding life in the universe, we think. Astrobiology has found many exoplanets, and some are habitable. Many are
Yep.
habitable. They're Earth-sized. They probably have water. They could have atmospheres. The technology is almost there to find microbes, to find planets where there's microbial life. That technology is, those observations will be happening soon, and are happening already, but not for Earth-sized planets. And then there's so many habitable worlds in the galaxy now. We know that.
Hmm.
By extrapolation, tens of millions, maybe 100 million habitable Earth-like planets just in one galaxy. Then the logical question is, well, why have some of them not formed civilizations and technologies like we have? So the question arises, are there other intelligent civilizations out there? Can we communicate with them? And, astronomers have been trying to do that in various ways for decades. The reason it's scary is, and I don't know if you've read the Three Body Problem, but that's a well-reputed science fiction trilogy. And he didn't invent the idea, but the author uses the dark forest idea. And the dark forest is an explanation for what Fermi, there's this thing called the Fermi paradox. Enrico Fermi, back in the 50s, understood there might plausibly be a lot of life in the universe, and there had been plenty of time for it to become more advanced than we are. And so he just said, well, where is everyone? And the fact that we haven't seen signs of that intelligent technological life leads to what's called the Fermi paradox, the where are they? And one answer to the Fermi paradox is leads to this dark forest idea, which is that because you don't know if an intelligent civilization, which is likely to be superior to you because we barely can leave our planet, our technology is quite young, you don't know whether that is a malign or a benign civilization, so you don't take the chance. So you keep very quiet, so you don't betray your existence, and because civilizations are competing for resources and they're finite resources, so it's not that everyone is necessarily warlike or aggressive, but there's a logic to sort of keeping quiet, because in the dark forest, many people are hunters and they will kill all the other creatures in the forest. And so it's pretty hypothetical, but it's a possible scary issue arising from life in the universe.
What's your gut feeling regarded to that thing?
I,
Are we alone?
my gut feeling is that it's not an issue in the way that that idea says it is. I don't think we're alone. I mean, because statistically, the number of biological experiments is potential biological experiments is vast, and
Yep.
it's implausible that none of them become real experiments, and then it's even more implausible that none of them develop some level of advanced intelligence and maybe technology at all. The universe is such a big place, and there's so many of them. So I think that's true, but I think there's so many reasons why we might not know they exist. So I don't actually think the Fermi paradox, as it's called, is really a paradox. I think that's an incorrect characterization of it, because there's many
Yeah.
reasons why we might not know they're there. They might not care they might not travel. The universe could be full of intelligent creatures without technology, like elephants and dolphins, and they're not going to travel and check out other star systems. The mismatch in technology could be very large, to the point where they don't care about us. I mean, we might be beneath their consideration because we're so primitive. I could make a list. There's people have written books about this, and there are dozens and dozens of reasons why intelligent civilizations might exist, yet we don't know about them, or they haven't contacted us yet.
Yeah. It can be like aliens might have already visited Earth and they are disguised as our friends or families also.
Well, I have to deal with that all the time when I give public talks. I'm always asked about UFOs and aliens visiting. And, as a scientist, I just say, well, okay, that's not implausible. It's not impossible. But what's the evidence? And the evidence, there isn't evidence. I mean, UFOs are just is just too easy to explain UFOs. Most UFO sightings are actually Venus or weather
Hmm.
balloons, very conventional, mundane things like that. So I don't take at face value the claims that aliens have already visited, because the bar is set very high for evidence. You just need to provide
Yeah.
a physical artifact, something that you can show is not terrestrial or not our technology. And in all the decades and decades of UFO sightings, nobody's ever provided that kind of evidence. It doesn't exist.
Yeah, these things are quite popular because no, number one thing is that because it's interesting for us, uh, it provides some sort of entertainment, and the news related about it, like just few days back, I guess, not few days, like few weeks back, I think, we got to hear something from the Pentagon that they have revealed some sort of images, and that also makes something concerning about the aliens and the terrestrial lifestyle. So due to this also, we think that
Yeah,
it's
I mean,
possible.
the U.S. military and other militaries have seen what they would call a UFO. They actually rebranded them in the United States to UAP, unidentified aerial phenomena, because
Yep.
they wanted to avoid the stigma historical of UFOs. Although UFO just means unidentified flying object, it doesn't mean alien. It just
Yeah.
means you don't know what it is, which is fair. So those military sightings are interesting, but the military does not claim they have any evidence at all of aliens visiting. They don't know how to explain everything that they have seen, that military pilots have seen. Okay, that's fine. It's hard to explain stuff in the sky, stuff in the air, and out in nature. It's not a controlled environment, so you're usually dealing with insufficient data or difficult data. You use eyewitness reports, are very unreliable, hugely unreliable. That's proven with tons of research. So, like I said, the bar is set very high for anyone
Yeah.
claiming aliens are visiting or have visited, and most scientists just say no. It's, you can talk about it, it's fun. You can speculate, it's fun, but it's not a real thing.
Suppose if we get any sort of message from the aliens in the coming future, so as a person from Earth, should we respond to it or ignore it?
Well, relating to this idea I mentioned earlier, the cautious thing to do
Yeah.
would be to not respond, to stay quiet. And so most for 60 or 70 years, we've been doing SETI, the search for extraterrestrial intelligence, with radio telescopes and optical techniques too. And that's a listening experiment. So we're listening for artificial signals that have a technological origin. They couldn't be produced just by astrophysics. And those searches have never succeeded. They're getting better and better all the time because our technology is improving. Um, and then it's a much more smaller activity and more controversial if to do the transmission experiment, to actually speak out into space. And it's controversial. Stephen Hawking, who I just mentioned about black holes, before he died, he said, no, we shouldn't do it because they might want to kill us. So,
Yeah.
and he's right. There's certainly an argument that says to be cautious, since you don't know what's out there or what their intentions might be, and they're more likely to be more advanced than you, so you can't match up to them. The cautious position would be to not betray your existence by trying to communicate actively.
Yeah. By this logic, uh, did we did mistake by sending Voyager to the space so that if we meet any aliens, then they can get know about us?
I think every experiment so far is not doesn't carry much risk. The Voyagers and the Pioneer spacecraft, those
Yeah.
four have left the solar system, all with messages on board records and flags. But they've barely left the solar system. They're in interstellar space, and their trajectories are such that they won't even reach the nearest stars for tens of thousands of years. So those are really things almost at the edge of the solar system. They're not realistically traveling through space. The messages we sent with radio telescopes, the famous one from Arecibo in 1974, that was aimed at a globular cluster that's 13,000 light years away. So it'll be 26,000 years before you could hear anyone.
Yeah.
So that's not very dangerous either. So basically, in practice, and then there's another thing that I had to comment on a public radio station a few years ago. There's the idea that we've been leaking radio and TV communication into space since the age of TV and radio. So since 1950s, we've had 100 megawatt transmitters sending radio and TV signals around the world, and those radio and TV signals leak out of the Earth's atmosphere through space. And so an argument has been made that we're betraying our existence inadvertently by those leaked signals. But if you do the math, that's not an issue either, because those signals diffuse through space and they weaken quite rapidly with distance, to the point where even before they leave the solar system, they're weaker than the microwave background, the cosmic hum of the Big Bang. So there, again, there's no way aliens could detect the fact that we have radio and TV transmitters.
Yeah. Like of aliens, another thing that we constantly hear in theories is about wormholes and white holes. So, does this really exist in reality?
Not in reality, because we have no evidence for them, but they're not ruled out. So that they're in an interesting category, because general relativity, the theory of gravity that predicts black holes, it
Yep.
also allows for the possibility of what we would call a wormhole, which is a connected region of space-time that connects two different locations through a tunnel, if you like, in space-time, and a white hole where energy goes in one side and then it comes out on the white hole side.
Yeah.
So general relativity allows mathematically and physically for those things to exist. They're not going against general relativity to talk about them, but we have various ways we might detect wormholes or white holes, and we've never found one. And also, I think the more basic reason is that space-time in our universe is actually quite boring for the most part. Space-time is really flat. The universe
Okay.
is spatially flat. So it's not all convoluted and tessellated and
Yeah.
like a Swiss cheese, or it's not the kind of space-time where you'd expect to see a wormhole.
Like watching all the movies, one thing that mostly comes into my mind is like, suppose I enter inside a wormhole and I want to come back to my current address. So, coming back from wormhole to the current place, is it possible? Just from my queries from the movies.
Yeah, not necessarily, because these wormholes, like black holes, are event horizons, so they're points of no return. I mean, it's possible
Okay.
to have you could maybe have a one-way transmission, but you can't go the reverse way. If there's a black hole on the other side, you're inside that event horizon, so it doesn't allow two-way traffic.
And what is the biggest blocker in the current time for the interstellar travel then?
But we're using chemical energy from a rocket, so everyone's very impressed,
Yep.
suitably impressed by SpaceX and Blue Origin sending rockets up, and they're much cheaper. The innovation in the private space, commercial space, is due to reusable rockets. So they've brought down the cost of putting objects into Earth orbit by a factor of 100, actually, in the last few decades. That's dramatic. That's opened up the whole space activity. But even the Starship from SpaceX is just a cousin of the Saturn V rocket. It's the same
Yeah.
chemical energy, and chemical energy is 100 million times less efficient than fission or fusion. So we're using very, very old-fashioned chemical energy for our rockets, and that will keep us in the solar system, basically. We'll never get to the stars with the rockets we have now.
So, how long does it take to get rid of this chemical energy then?
Well, the part of the problem is there's not much money actually being spent on research. So the amount
Okay.
of money spent on research and development on alternative propulsion technologies is really modest. I mean, NASA spends a very little amount on it out of their big budget. Other space agencies similar. So really, we're not investing in it. So it's not going to happen soon, because these are not easy technologies to develop. I mean, in principle, physics of doing it is understood. We know how to
Yeah.
make a fusion engine or fission engine or various other technologies. We can't do antimatter propulsion. That's science fiction. It will stay science fiction. But we know how to do the technology, the engineering and the physics of it are understood. But it's billions and billions of dollars to test it, develop it, build a small scale, and then scale it up to one that could carry humans. And we're not even investing enough for that to happen in a few decades. So I don't know when we're going to get it. It's not on the table right now.
Yep. And when we are actually talking about universe, one thing that we commonly hear is that the universe is constantly expanding. I mean, you also said that the universe is a flat line. How do we actually get to know that the universe is expanding?
So
Anything that measures it?
yes, it's been the first observation of it was almost 100 years ago, 1929, Edwin Hubble. Um, he actually built on work of other people who don't quite get as much credit as Hubble does. But in the late 1920s, people observed the spectra of galaxies, and they saw that light was shifted to longer wavelengths, or stretched. Um, and the interpretation of those redshifts of galaxies in general relativity, the gravity theory developed just a decade before, was expanding spacetime. And so the redshifts, the observation of galaxy redshifts by Hubble and others, became interpreted in terms of expanding spacetime through general relativity. That was the theory that accounts for it. And then that leads you to a Big Bang model, because you run time backwards, and then an expanding universe must have been smaller, denser, and hotter billions of years ago, and that's what we call the Big Bang. So the evidence for that is incontrovertible. I mean, evidence of galaxy redshifts and the expansion of the universe explained by general relativity, that's been around, like I say, almost for a century. And
Yep.
it's pretty foundational to cosmology.
And is it the general relativity theory that we get to know about the existence of universe, like what happened billions of years back?
It does explain the history of the universe, but it doesn't answer the questions people always want to know, like what caused the Big Bang, what came before, is there anything
Yeah.
outside the universe? The theory doesn't answer those questions. You can speculate, and people do, but it doesn't answer it. So the theory gives you a story, a physics-based story of the origin and when it was, 13.8 billion years ago, and then a description of how space-time expanded for those 13.8 billion years. And it's a good story.
Yeah.
It's tested at different levels. We have tests of the Big Bang going back to about a microsecond after the Big Bang, so into the first fraction of a second, and then many tests later on in the history. So it's a pretty robust theory, actually.
So if the universe is actually expanding, in what speed is it going? Is it in the speed of light or even more than that?
No, it's less. In the local universe, we measure that. So we measure the local expansion rate just by looking at the nearby galaxies that are moving away from us. And the
Okay.
measure of the expansion rate is called the Hubble constant, named, of course, after Edwin Hubble. And the number on that is 70 kilometers per second per megaparsec, which means every million parsecs, or 3 million light years, you go away, a galaxy is moving 70 kilometers per second away from you. And if you go twice that distance, it's moving 140 kilometers per second away from you. So that's how you put a number on the speed of expansion. And that's a lot less than the speed of light. So it's that the local expansion rate is, it's not tiny, but it's modest compared to the speed of light.
Okay. And this parallel universe actually exists?
Well, it's beyond visibility. So almost by definition, we are limited by regions of space where information could reach us, typically light or
Yep.
other form of radiation. And we can only see uh, a distance corresponding to how far light could travel in 13.8 billion years, the edge of the universe.
Yeah.
And we can't, and we know that there could well be space-time beyond that. We just don't have information about it. That's not a parallel universe. That's sort of what cosmology would call beyond our horizon. It's just a part of our own physical universe that we can't access because information hasn't reached us. As to parallel universe, is a concept that sometimes relates to the Big Bang. If our space-time started expanding 13.8 billion years ago, maybe there were other space-times that expanded and they're independent of ours, and that would be a parallel universe, the multiverse idea. That's not tested, and it may not even be testable, but it's a speculation out of Big Bang Theory, which goes beyond Big Bang Theory, because like I said, Big Bang Theory really just describes the history of
Yeah.
our universe quite well. It doesn't speculate, it doesn't answer the question of outside or beyond or parallel universe or multiverse or before. It doesn't answer any of those questions. But people,
S-
even astronomers, like to speculate.
Yep. So in that speculation, we can also assume that another laws of physics can be involved there.
We don't have all the laws of physics in hand to
Yep.
understand everything about the universe. We know we're missing some physics. We know we're missing the physics to explain dark matter, which is the biggest ingredient in the universe, and dark energy, even bigger ingredient. So the two main ingredients of the universe, apart from the normal atoms we're made of, are still mysterious or enigmatic, and we don't understand them, and they probably involve new physics. So we're missing that physics, and then we're also missing the physics that would allow us to unify quantum theory and general relativity. That was the quest of Einstein in the last part of his life, and he didn't succeed, and nobody has since. So unifying those two foundational physics theories is an important thing to do. It's extremely difficult, and no one succeeded yet. And nobody knows what a unified theory of all the forces would even look like. People talk
Yep.
about string theory as one idea, but it's just one idea. So yes, there's definitely physics that we still have in front of us. We haven't got all the physics there is.
And as you just discussed about the dark matter, so actually, is dark matter really dark, or we don't know its color?
It's dark only in the sense that whatever dark matter is, it doesn't interact with radiation. It's almost what defines it. It's we think some fundamental form of particle, subatomic particle that's not observed in the lab, and
Okay.
is permitted in physics. I mean, it's an extension of standard physics, but we already know physics is incomplete. So if it's a fundamental particle, it's just a particle that has very weak interactions with radiation, very weak. So it doesn't absorb light, it doesn't emit light, it doesn't scatter light, and then therefore it's dark. We can't see it.
So kind of like black hole, just it does not absorb it.
Well, it does have a gravity, so it does have gravity. If
Yep.
even if it doesn't have radiation, and so we observe it through gravity. And the dark matter has been diagnosed and studied for half a century, really, since the 1970s, by the way things move in space on
Yeah.
large scales, the way galaxies rotate, the way galaxies move in clusters of galaxies, the way light travels through the universe and gets bent by mass, dark matter too, and that's gravitational lensing. So we have tools to diagnose and study and weigh dark matter on big scales. And they give pretty much this consistent answers. I mean, it's just a consistent story that we're telling. But those measurements just say how much of it there is and where it's distributed. They don't say what it is fundamentally, what physical nature it is.
And can dark matter also be created?
No, well, maybe if we knew what it was, if we finally identified a subatomic particle that accounts for it, then physicists would try and figure out ways to create it. But since we don't know what particle it is, assuming it's a fundamental particle, we don't know how to create it. We just try and measure it in different ways to figure out
Yeah.
what it is.
Because I asked you this is because one works in YouTube is quite popular is that dark matter can also be made in lab. So this works has been spread quite a lot in YouTube. So this is also a thing that needs to be concerned, I guess. And
Right. I
yep.
mean, when you don't know what something is, people walk into that space and say all sorts of things. So we should be humble and modest about our level of ignorance about dark matter. Like I said, speculation is fine, and as
Yeah.
long as you know it's speculation.
Yep. So I guess this is the end of our video. So thank you, Chris, for a wonderful time.
Oh,
Uh,
okay. It was a good
uh,
conversation. I appreciate it.
Thank you so much.